In this section, I will talk about random class. The random class is used to generate random numbers. The random class is part of the java.util package. Java.util package. So if we want to use random object, you need to import java.util like scanner class. It provides methods that generate pseudo-random numbers. A pseudo-random number is generated by some algorithm. Although generated by some algorithm, it is difficult for us to predict the number. A random object performs complicated calculations based on a seed value to produce a stream of seemingly random values. In this section, I am going to teach you how to create random object in Java and use these methods to generate a random number. After creating a random object, we can use nextInt method. NextInt returns the next pseudo-random integer uniformly distributed int value from this random number generator's sequence. Let's see an example. A random object can be created like this. Random class, a reference variable, new keyword, and constructor for the random number. And then nextInt method is called here. Since the range of integer in Java is like this is the range of integer. Any number between these two numbers can be created. And a random integer is created and then returned to this place. And then store this value to n. I run this code several times and got these results. These numbers are between these two numbers. If you run this code, you will also get various values, probably other than these values. There is a nextInt method that has one parameter. Here, nextInt a, this is a parameter. NextInt a generates a random integer number between 0 and a minus 1. Here a is an integer number. For example, at first I create a random object and then I put 10 here. This means that the number between 0 and 9 will be created here. This is the result. This result of running this code several times. All of the values are between 0 and 9. And I changed the value into 35. And I also run the several times, and these are the results I got. Since this is 35, the number can be generated is between 0 and 34. Now I changed this part like this. NextInt 10 plus 5. Then what is the smallest value that we can have here? And what is the largest value? Since this can generate from 0 to 9, this can generate 0 to 9, and then we add 5. Then finally we can have from 5 to 14. Okay, from 0 to 9 plus 5. This becomes 5 to 14. So if we run the code, we will get the result between these two numbers. Let's see an example. This line is very important. If we want to create a random object, you must import java.util package like this. And first you need to make an object of random class. and n1 will get next int result, n2 will get next int 10 result, and 3 will get next int 100 result. So n1 will have a number from the range of integer, and n2 will get a number from 0 to 9, and n3 will get the number from 0 to 99. I ran this code several times, and these are the results I got. So I hope you copy this code into your Eclipse and run it several times and compare the outputs with this. Next float method returns the next pseudorandom uniformly distributed float value between 0.0 inclusive and 1.0 exclusive from this random number generator's sequence. So this is important. 0 is inclusive and 1.0 is not inclusive. So you cannot get 1.0. First, we must make an object of random class, and then I called next float twice. And I found out the result of this next float. So as you see here, I have a random float number twice. So this is pretty easy one, but one thing you remember is that 1.0 is not included. Now I'll explain next double method. Next double returns the next pseudorandom uniformly distributed double value between 0.0 inclusive and 1.0 exclusive from this random number generator's sequence. So for example, to use next double method, you must make random object first, and then I will call next double twice. And I get the random double number twice like this. This is pretty much the same as next float. The difference between the two is the difference between a float data type and a double data type. Double data can represent a much smaller or much larger floating point number than float data type. So if you need a very big double number or very small floating point number, then use next double instead of next float. This example is from the textbook, and it shows generating random numbers in various ranges. So at first we need to import java.util package, and then we generate a random object, and here next int will give a random number from the range of integer values, and next int 10 gives from 0 to 9, and next int 10 plus 9 will give 1 to 10, because next int 10 will give 0 to 9, and we add them. So this will give 1 to 10. And next int 15 plus 20. Next int 15 will give 0 to 14. And then we will add 20 here. Then we can have 20 to 34. And next int 20 minus 10. Next int 20 will give from 0 to 19. 0 to 19, and then minus 10. So 0 minus 10 is minus 10, and 19 minus 10 is 9. So we can get from minus 10 to 9. And next float will give a random floating number from 0.0 to 1.0. And here 1.0 is exclusive. And I will explain this part in the next page. If we try to convert a floating point number to an integer using casting operator like this, then the fractional part of the floating point number is truncated. This example shows that. Here I declare 3 floating point number float. So f1 is 5.1, f2 is 5.5, f3 is 5.9, and then I apply integer casting to all of these floating point numbers. And then I got the result like this. This means that if you apply integer casting to floating point numbers, the fractional parts, here 1 and here 5 and here 9, are all truncated. And like this, a double value will also have the same result. Here D1 is 2.1, D2 is 2.5, and D3 is 2.9999. If I apply integer casting to all of these double values, then all of them gave the same result, 2. This means that if I apply the integer casting to double value, then the fractional part, here, this part, are all truncated. I want to find the result of this. That is, I want to find out the range that num1 can be in. So at first, I will find out the range of this. So generator dot next float times 6. At first, generator dot next float will give from 0.0 to 0.9999 because next float will give 0.0 to 1.0, but 1.0 is exclusive, so I write like this. And then I will multiply 6 to here, multiply 6, then it will give 0.0 to 5.9999, something like that, because 0.0 times 6 is 0.0. And this is just less than 1. If you apply this number to 6, then we will have the smaller number than 6. So I write like this. This is num2. Num2 can be between these. And then I will apply this expression. Then at first I apply integer casting. So I apply integer casting to this number. Then it will give 0 to 5. Because if you apply integer casting to floating point number, the fractional part will be truncated. So if I apply integer casting to 0.0, then 0 is the output. And then if I apply integer casting to this number, then 5 will be output. And then I need to add 1. Add 1 here. So I need to add 1 to this number, then it will give 1 to 6. Let's do quick check. Given a random object named Jen, what range of values are produced by the following expression? Next int 25 will give from 0 to 24. Next int 6 will give 0 to 5, and then we need to add 1, so 1 to 6. Next int 100 will give from 0 to 99. So we add 10 gives 10 to 109, 109. And next int 50 gives 0 to 49. So plus 100 gives 100 to 149. Next int 10 gives 1 to 9. So 0 minus 5 is minus 5, and 9 minus 5 is 4. So minus 5 to 4. Next int 22 is 0 to 21. So 0 plus 12 is 12. 21 plus 12 is 33. So this is the answer. Let's do some second one. write an expression that produces a random integer in the following ranges. 0 to 12. This is then done next into 13, right? And next one, 1 to 20. Since this is not start from 0, I think we need some number to be added, right? So then dot next int 20 plus 1. This gives 0 to 19. And then plus 1 gives 1 to 20. And this is the same. Since this is 15, I think we need to add 15. So then the next int 6 gives 0 to 5. 0 to 5 plus 15 gives 15 to 20. And about this one, this is minus. So we can have 0 to some number. Then this time we have minus value. So then the next int 11, we need minus 10. Okay. So I hope you practice a little bit about this part.